Hey everyone, I'm TJB Chris, coming to you from what is now called the Charles D. Tandy TRS-80 Emporium. That's what I'm calling the room now. Wife offered me to make a crafty project for the room, so I added a little Tandy flair in the way of the Tandy Corp Hourglass from Deskmate 3. I really like that logo, I really like that color scheme, and gave that to the wife, and she pulled it off expertly. It really lent itself to needlepoint, and we decided to add this nice little whimsical name to it to just give it a little more flair. So this is now the Charles D. Tandy TRS-80 Emporium. I didn't come here to tell you that. I came here to talk about this, my TRS-80 Model 12, which is involved in yet another project. You've seen this machine many times before on this channel. It got its own intro video when I got it. It was a terminal over a 300 baud modem connection to Xenix on my Model 16 once. It was a terminal to my PyDP-11. It's my default BBS machine. One of the other things I did with this was I installed a 3-slot bus expansion, which had trouble at every turn, but did end up going in and does work, and that is currently still in the machine. But now, I'm going to follow on to that project and make the machine even better. So in today's video, I'm going to talk to you about my current project, a Model 12 card cage chassis replacement that I'm currently in the process of making. I'm going to show you a little bit of the process about it, and I'm going to talk to you a little bit about the Model 12 and why this is necessary in the first place, and how I got here. Let's start with the Model 12 and why this is necessary in the first place. So this is a 7-slot backplane that works in the 12, 16B, and 6000. The Model 12 is really a consolidated version and restyled version of the original TRS-80 Model 2. All of the electronics that are not the keyboard and video were consolidated from separate cards onto a single motherboard at the bottom of the machine, or as IBM would call it, a planar. That expansion board, or that motherboard I should say, had a single expansion slot into which the video card was inserted. And then that video card is mounted to a metal chassis that sits behind it, and that also holds up the cooling fan and blocks access behind the back cover if one were to open it and stick their grubby little fingers in there, while still allowing access to the floppy disk expansion connector, which is on the motherboard. Now, the Model 12 did come with some enhancements over the Model 2. It came with either 1 or 2 8-inch, half-height, double-sided floppy drives, and these are the kind that don't run continuously. They don't have the AC motors. It came with a pleasant green phosphor display for easier on-the-eyes viewing. It came with additional function keys on the keyboard, which the Models 2 and original 16 lacked. It did come also with 80K of RAM on board so that it could run Tristos 4.2 out of the box, because Tristos 4.2 needs the extra 16K. Beyond that, it did get some external restyling. As you can see, I actually really like the style of this machine, but it did not get smaller. While they consolidated the inside, the outside kind of ballooned a bit. This machine does not have floppy drives. It never did when I got it, but it has this nice Lotharek as a floppy emulator, and that's actually perfect for it. So that's where the Model 12 fits in the line. It replaced the Model 2, but they took away one very important thing when they consolidated it. You notice I didn't talk about expansion slots. And that's because the video card takes up the single slot on the board. But Radio Shack did make available a card cage expansion that you could add for a low, low price, plus installation by your local Radio Shack, of course. That added this backplane along with a metal chassis, which you're probably looking at right now on your screen, to be able to allow you to use or install up to 6 additional cards, because the video card would go into one of these slots. And this would let you use any of the Model 2 card accessories, graphics, high-res graphics adapters, hard disk interfaces, ArcNet boards, any of the many adapters available. You could even add the 68,000 CPU and memory card complement down the road if you wanted. Those of you going straight to Xenix or with plans for 68,000 software would have gone with a 16B. It's more cost effective, or later the 6000, but was the Model 12 still in the line when the 6000 came around? That's a great question. I'm going to have to look. Anyway, you wouldn't have started here because it's too expensive to do the upgrade piecemeal. But for those of you that want to run Model 2 software, add a little expansion but not go full hog on the 16B or the 6000, the Model 12 is your automobile. Now, today I'm going to talk about the process for getting this designed. Of course, I'm not designing the electronics. I designed this to be a crude but serviceable part for me. I started this, it's now late November. I started this in mid-October, and I've been shooting footage at most of the steps along the way. So I'm going to show you various parts of the build, how we got here, what we've been doing, and then I'll use some of it for B-roll as I'm jabbering along for what I've done. But I'm going to go through making this project, and then we're going to mount it and fit it. And one of the first things we have to do is we'll get this machine apart and we'll take a look at its current state. And that is what we're going to do right now. But first, one more thing. I almost forgot. About 2 weeks into the process here, I found out that the demand for this may go beyond just me. There may be more interested parties in my little plastic chassis thing that I'm making for this. So with that in mind, this is only the second thing I've ever made. For those of you that are coming in new, if you're expecting polished, you're expecting wrong. But it should work. And with that said, now let's actually get to taking this thing apart and get into the project, right? Right. And here's the 12 from this side. So you can see the empty drive cage, screws in place. You can see the top here with a CRT mounted in it. This is the original design where it was all one piece. Later 16Bs in the 6000 actually had the top come off, but the front bezel stayed put. And I don't have that machine in either case. We've got power and video. This here is where the video card normally sits, and that's because the video card now is in that expansion back plane that I'll show you momentarily here, but this brace holds the card in place and it mounts up against this metal chassis, and this is what I was talking about here. This is the mount piece. Here's your fan mount. Back here is the grubby little fingers protector. This I mounted here because of the expansion card that I put into the 3-slot bus, which I ended up not using very much. I don't use CPM a lot on this thing, and this particular thing was finicky with it anyway. But looking at the inside of this thing, you can see it's a relatively tight fit, but there's the video card and there's that IDE adapter, bus adapter for the SD card interface here that we're not going to be using. So what I've got to do is get this apart. The new design takes into account the cooling fan, so you're going to want to save the screws for the cooling fan. You're also going to want to save these screws for the chassis as well, because we're going to need them actually to install the new card cage assembly. So this isn't actually going to be a complete waste of the screws. You probably will find a use for pretty much all of the screws that are currently installed. One of the issues with getting this apart is when I did this card cage project, I had to up my grounding game because all this stuff is grounded out, but all the grounds were going to be replaced. So to do that, I made this jig, this little grounding thingamawhatsit, and jig is not the right word, but I'm brain farting on it, and wrapped it in electrical tape so as to not have floating metal. And actually, with the new card cage, because it's going to be plastic, there's going to have to be a similar situation because there's not going to be any of this grounding. Now I need my cutters. This calls for a beer root. Calls for a real one, but it's not that time of day. Those of you who have noticed the A&W on the channel before might be wondering why Barks. Because it was on sale. And I like them both enough. Okay, this harness will definitely be done better next time. I'm going to chuck it, actually, because it is nothing but trash now. It's done its job. Okay. We've now separated the keyboard cable. What I need to do now is start to get this apart. Alrighty, we have the 3-slot expansion adapter, which I put in. These are the Hans adapters. I'll say Hanzo 1 and Hanzo 3. These are really nice. And actually, if you have a Model 12 and you don't have 68,000 dreams or need more than 3 expansion slots and honestly do a better job than I did of putting this in, you could use this for a hard disk interface card or a graphics card and have all the expansion you need. So definitely check out, I'm going to hold on to this one in case I need it again, but you should definitely check out Ian Maverick's site. I'll put a link in the description if you want one of these. Okay, video card comes out, and you can see out of an abundance of caution I taped off the top. It wasn't touching, but it was close, and I didn't want to take the chance. Oh, that's not good. Took off the, I didn't realize that was a thing. Took off the masking there. Oopsie. Shouldn't be an issue, but ooh. Okay, mental note to self, folks, and I really should have thought this through. If you're going to put adhesive on things like this, you're going to do that to it. Oops. And then this is the somewhat crude, but honestly, I'm somewhat happy with this build. So this is the Hanzo 2 adapter here, and this is my IDE CF that I got, I'll say from TechSelect, but I don't remember. Takes the TRS-80 expansion interface bus meant for a 134 and adapts it to an IDE bus, and then this does the inversion for the Model 3 signals, the Model 3.4 signals, because they're inverse from this. So anyway, I put this together. I used nylon screws and I used some old PCB and fashioned it together as one card. I'm actually not unhappy with that looking at it now, kind of in hindsight. Sometimes I look at this stuff and cringe, but I'm actually not too unhappy with it. All right, this here is the floppy expansion, and this actually is going to have to get rearranged because I mounted it oh so conveniently here. This is my 50 to 34 pin NF6X adapter. So this is going to have to come out. Additionally, coming out, is the 3-slot expansion itself. And honestly, aside from the fact that I didn't really properly account for the cooling fan or video card height, and I think for the cooling fan I was mostly worried about the cooling fan nuts, I didn't really account for that in doing this way. So if you're looking to emulate this, don't do it the way I did. In fact, someone makes a 3D printed card slot cage for this this Hans adapter, Hans 03. So I highly recommend you just do that if you have the means, or to 3D print it yourself, or go someplace and get it printed. So a closer look at what I have to do now, or what the chassis is going to entail. You can see I have this side chassis here. It's got 2 screws here, which I actually won't be using. The existing Model 16 version does not. Instead, it's got these 3 screws on the side, into which I'll be installing the screws for this. Now, note that this ground will have to be accounted for. Additionally, I have 3 screws over here, which were somewhat in use to hold the metal cage on, and we'll be using all 3 of these. And then what I essentially have to do is I have to replicate the sides, the top, and that's about it. One other thing that we're going to have to do is get power to this, because it does need to be powered. So we're going to have to deal with that as well. We'll get there when we get there. The first thing is going to be about the physical stuff. Also, the cooling fan, you'll notice I didn't go to the trouble of disconnecting it or anything. That's because it is necessary. We're going to be using the cooling fan. So all of the parts and everything are over here that I need for the chassis. You're going to reuse these screws to attach the card cage assembly itself, and you're going to reuse these screws to attach the fan to my new card cage. All right. The current iteration of the card cage does not yet have the fan in it. I didn't have the dimensions, which is why this is actually being filmed before the final part is done. I've got it pretty much ready to go. I just need to put the cuts in for the fan. So now that we have an idea of what it looks like with backplane installed and what we're dealing with in terms of chassis and the overall structure of the machine, I've basically done this in 3 main phases thus far. The first phase would be mock-up. Let's take a look at that. And I'm just printing the very first part here on the screen here. I just have the right side of the card cage. I've taken the 16B apart. So you're asking yourself, well, TJB Chris, why'd you take your Model 16B apart? You're working on the Model 12. Because the 16B has a card cage in it that I can use for measurements, that's why. So I took it all apart, dissected the card cage, and we're going to do this in stages. So right now I have the first, this is going to be the right side of the cage printing, and we'll see how this goes. Now this is a mock-up version of this. This is not going to be the final product. What I'm going to do with this is, you can see right here where this end, it actually flares out on one side and extends down over the chassis on the inside of the machine. And on the other side, it actually kind of goes out to the back there. And that's going to be just the best on camera. This is the best camera work I've ever done, folks. One thing I don't plan to do for the moment is there's also back edges to it where there are screw-ins for the brackets to hold the card and the cards in place. And if it becomes a problem, I'll work on it. Well then, it's the next morning. In fact, it's 8:10 the next morning, to be exact, according to Captain Micronta there. And we are just starting to 3D print the third and last piece, which is the top. So again, these are prototype pieces. They're only 1 millimeter thick for the sides. But overnight, I finished printing the last side, and this is what we have now. So we'll take a look at these kind of mocked up against the 16B in a minute. In the computer room again, here are my pieces. So let's do this. Let's put the 16's card cage, or the 16's backplane, into the board. So here we go. So if I hold this piece up like this, it lines up really nicely. It goes right to the edge of the chassis here, like it should. And if I hold this piece up here, I just hit the mic. I hope I didn't mute it. Did I mute it? I did not. Okay, woohoo! Saturday morning, folks. All right, and here we go. So I have the overlaps for the screw holes here, and this fits, and you can see, actually, you can't probably see it, but there's a line where the metal chassis, the metal card cage collided with the chassis and kind of wore it in, and that's what I've got here. So now the top will print. I think this is going to work. We'll see, but I don't want to get overconfident, but this feels like it may work. What do you think about that? Now that we've moved on from mock-up, I'm now to the point where I want to get something a little more structurally rigid. So I went into the phase of prototyping, where I designed pieces that had some level of integration with the chassis. So for example, the left side here, oh, I got it upside down, you dumbass. Screw holes. The left side here and then the right side here, which, as you can see, has a bit of an overhang, and the reason for this is I want it to rest on the chassis, but then also line up with the screw holes. Now, this isn't final in that, you know, it's missing a lot of structural support and things, but it does give me a much more sturdy and easy way to kind of finalize where the thing's going to go, how it's going to align with the card cage, and whether the screw holes all align, things like that. In fact, let's put this one together and we'll see what it looks like. By the way, also included in there was a top. Notice my name on it. The old top was solid for RFI shielding. This doesn't need to be, and actually for the helping ventilation, I didn't do it. This is really just going to deal with side-to-side structural rigidity, but let's get to building this and we'll see that. Alright, the top is on. I'm going to insert a couple of screws as I walk in front of the light into the side here. Let's see, these holes line up nicely. I'm pretty happy with that. Now what we have to do is see if the cards fit. So not only do they need to fit in the guides and slide fairly smoothly, like I've got a little tight here I've got to deal with, but we can trim that out. We've got to do it on the top and bottom, but also see if they line up with the slots, because if they don't, then we're going to have a bit of an issue. Now the cage is pushing on the card, so it's warping a bit, but if we go to the top, we can see that, yeah, it's a little tight, but that can be trimmed out. But in looking at how the card interfaces with the connector, it's actually quite good. I just have to trim this out a little bit, and I can do that with the screws. And you're going to want to test fit every slot naturally, but that is much, much better. I'm very happy with how that's going. The top's a little tight, but if I really need to, I could probably trim it out of the top. I think the top's a little too tight. But again, I've already addressed that in a subsequent revision. But that is it. That's pretty much what the card cage looks like installed in this rev. So the next plans here that you're going to see, the fan is going to attach right to the side here. I'm going to measure this out. This is not perfect, but I don't really have a good way. It's too big to attach to the top, and this would have to be much sturdier. And the only other option is the turbofan mod. And originally when I did this, I was going to take this fan out and do the turbofan mod. The turbofan mod is a mod wherein you drill a hole in the back cover, the back access cover, and then you attach a 120 volt fan running the 120 volts over to the terminal block over here, giving yourself some extra blades there. And then the machine forces a lot of air in through the card cage. The original card cage designs for this and the 16B retain heat, and the original fan was off to the left here and vented out to the top, and it was ineffective for a full complement. Honestly, if you were going to do the full complement of cards in this, I probably would still consider the turbofan mod, because it does move more air. You can use a 12 volt fan in its place, but be warned, if you do that, you're going to have to recalibrate your power supplies with the machine under full load, because that's more load than the power supply was originally calibrated for. So that's going to be something you're going to want to do if you go the 12 volt fan route. Anyway, so that's where that's going to go. I'm going to attach that. You're going to need the screws to do it, so I have to cut this into the side while leaving the holes, not interfering with these slot guides, which should be doable. And then that's really going to be it. Though the other thing I meant to mention, I'll show you now, is the top cover nuts. Alright, so it's kind of visible but kind of not. And this is where I just don't work well in the 3D space, but I've already addressed it. You can see here these nuts are way too close to the edge. And while I got them in there, they are way too close for comfort and difficult to adjust. So, you know, it's funny, I didn't crash into this and I left just enough room for the nut to fit, but when I measured it out, I was thinking in terms of the top and the thickness of the top. So what I did was I widened this section and then moved everything over a little bit so that we have more leeway. And that should make adjusting this out easier in case it's a little too tight. That's really all I did. This is a not final version of this, but this is really where I landed in the prototype stage. This is my latest prototype, with what I'm calling beta, my hopefully near final design coming. And that's going to come with some reinforcement because as I've been so informed, and I've kind of run into this, 3D printers and 3D printed objects don't do well with 90-degree angles without some work. And so I've gotten some reinforcement there, and that includes on the back of the back plane here. I'll get into all of that when you see those pieces. Those pieces have yet to print, but are about to right about now. But that's where we're leaving this. Let's check out the final pieces when they're done. So that's going to do it for what has become part 1 of my TRS-80 Model 12 card cage series. As you probably figured out, I was going to do this as one video, but it's getting too long. And why boil an ocean with one video when I can release 3? What you're looking at here is the closer to final parts printing. I've got the right side closest to the front and the left side on the back. And you can see I've got my fan hole in place and all sorts of other great stuff. So the reinforcements are there, my name's on it. That's where we are. I'm really happy with how this came out. We might need a few revisions, but this should be done printing tomorrow. It's probably about noon right now, and this takes about 48 hours or so to print. Then I'll do the top, which is going to take another 5 or 6 hours, and then we should be good to mount this up and try it out, and that's where we will pick up. So join me next time for part 2, when we mount this card cage, test out the card fitment, and then we'll move on, probably in part 3, to grounding and power connectors. Thank you for watching.